This is the warm-up for the first acid and base quiz. We're going to first start with the nomenclature of naming acids and bases, going backwards and forwards. Okay, so what you first want to do in this top section is you want to identify which one's an acid and which one's a base. So here, the first one, there's an H in the front, so we know it's an acid. Okay, and then once you identify which one is an acid or base, you then are going to count your elements. So if it's an acid, we're going to count. We have 2 elements, so we know it's binary. If it's binary, remember it has to start with hydro and it has to end in ic. So we're going to start with hydro, and then it has to have the root of the name, and then it's going to end in ic. So this element S, if you look here, S is sulfur. So we're going to write sulfur and then ic, acid. A common mistake here is people write hydrosulfic acid. If you do that, it's not a big deal, but sulfur is one of the few elements that uses its full name. So hydrosulfuric acid. Okay, next, number 2, we have an H in front, so we know it's an acid. We have more than 2 elements. We have 3 elements, so we know that there is a polyatomic. Okay, so there's no hydro because there's a polyatomic. Let's look for the polyatomic ClO2. ClO2 is right here. It is chlorite. Okay, so if we make a note here, chlorite, the ite will change to us, like meningitis. So you're going to change it to chlorus acid. Okay, next you have an H in the front, so you know it's an acid. There's 3 elements, so we know that there is a polyatomic. So you're going to look for CO3. CO3 is right here. It's carbonate. So I'm just going to go ahead and write carbonate here. When your polyatomic ends in ate, you're going to change it to ic, like I ate something icky. So this is going to turn into carbonic acid. Okay, here we see that there is an OH in the back, so we know that this is a base. Okay, bases are really easy to name. You're going to find this element, this metal, okay, Ga is right here. It's gallium, so you're just going to write gallium. And remember that OH is hydroxide. If you forget how to spell it, you can always look on this page right here. Hydroxide is right here. Your bases always have a hydroxide. Okay, so now let's go backwards. Here we have an acid, and it starts with hydro. So we know that it starts with a hydrogen, which is a +1 charge. Hydro means that there's only one other element. So you look at the root, nitra, it's probably talking about nitrogen. And remember the charges here. So if you forgot, it goes lose 1, lose 2, lose 3, and then skip, gain 3, gain 2, gain 1. Okay, so nitrogen is going to gain 3 electrons, so it's -3. So you're going to write nitrogen -3. So how many of each do we need for our charges to cancel out? I need 3 H's for every 1 nitrogen. Okay, next you see that it's an acid, so you know you're going to start out with a hydrogen. There's no hydro, it just says nitric. Okay, nitric means that this was a polyatomic. Ic was originally 8, so it was nitrate. Okay, so you're going to look up nitrate. Nitrate is right here. It's NO3 with a -1 charge. So I'm going to write NO3 with a -1 charge. You have a +1 and a -1, so they cancel out. So you just need 1 of each. Okay, here you have another acid. There's no hydro, so you know it's a polyatomic. So you have a hydrogen in front. Nitrous was originally nitrite, the polyatomic. So then you're going to look here. Nitrite is here. It's NO2 with a -1 charge. So you're going to write here NO2 with a -1 charge. You have a +1 and -1. That means you only need one of each. Okay, here we have magnesium hydroxide. So we know that this is a base. Okay, so magnesium is here. It has a +2 charge. So you're going to write magnesium has a +2 charge. Hydroxide is a polyatomic. It's here. It's OH with a -1 charge. So you're going to go back with this OH -1 charge. So how many of each do you need for the charges to cancel out? For every 1 magnesium, I need 2 hydroxides. So you got to put the parentheses there. Okay, so this bottom part, we're going to complete the table. So first we need to identify if it's an acid or if it's a base, okay, by looking at the names here. So here we have an OH in the back, so we know that this is a base. Here we have an H in the front, so we know that this is an acid. Here we have an H in the front, so we know that this is an acid. We have a here OH in the back, so we know that this is a base. All right, so how do we know if it's a weak or strong acid or base or a weak or strong electrolyte? We have to look at this light bulb situation. If it is bright, then we know that it is a strong acid or a strong base, therefore a strong electrolyte. That means there's a lot of charges and a lot of charges. So remember, strong means that there are tons of charges. They all separate. So it's going to create a really bright light bulb. Here, if you have dim, then we know it's a weak acid. It's a weak base. It's a weak electrolyte. If something is weak, then you only have a little bit of charges, and therefore the light bulb is very dim, so it still lights up because you have some, you just don't have a lot, and therefore it is a weak electrolyte. It's a weak acid or base. All right, good luck on your quiz.